First, I feel deeply honored to give a keynote on this conference about ethics beyond compliance, organized by ERSIM. It's really a great, really a great honor to me to be able to do that. And thank you, Claude, for the introduction. So I would like to speak today about what we call responsible artificial intelligence for short, but of course, artificial intelligence is irresponsible. And the long title is Responsible Development, Use, and Governance of Artificial Intelligence, of course, by human beings. Now, please notice on the top right that the title of the event is cut and you don't see it. Please keep this in mind. I'll get back to this later. Thank you. So,
sorry, just in order to get.
Okay. Thanks. So now, of course, I don't need to stay longer on this slide. As you know, artificial intelligence today is a technology. It's a research domain, of course, but I'm not speaking specifically about the research domain per se here. I will get back to that as well. But today, it's really developed and used in almost all domains in industry and service. When I say industry, I include agriculture, which is usually not industry, but it's really something that, as we all know, something that a technology that we are using in our daily lives. Of course, every one of us has interacted with an AI system just by making a search on the browser. And in businesses, this domain is really now more and more adopted. Not as much as we could think. Some statistics at the European level show that there is a real gap in AI technology adoption by companies, but this is, of course, encouraged, and it will evolve. Now, what I would like to point out here is that those domains are ranging from manufacturing to health, including justice, for example. They are also, it has been mentioned, used in, for example, delivery by drones, but also in warfare. So we rarely had such a technology that is so pervasive, so much adopted, and this, of course, raises some questions about it. Now, let's first clarify some definitions. I'm not going again to define artificial intelligence. I'm going rather to just set the ground to understand that we are speaking about a computational intelligent system. And as you know, when codes are put, next time they will disappear. So, but people start with codes. What is a computational intelligence system? It's a computational, which means running on a computer system, which means it's made from algorithms. This is all what a computer can do, is run algorithm by design. And they use data, and this data can be large amount of data, small amount of data, sensed data. And the purpose is, of course, to solve problems that we have, humans, in more or less complex situations. So we address some problems, and we use this computational system to do this. Now, the interesting thing about the computational system we are speaking about is that it uses processes that are usually pertaining to human capacities, like deductive inference, logic, or Bayesian reasoning. And the brain, by the way, does this. But also machine learning processes, which are different from human learning processes, although they are inspired by them, and which enables to build models from data, which are statistical models. And this is based on statistical classification. They can also improve their operation, their actions, based on technology called reinforcement learning, which will select the more appropriate action. And this is related to maximizing a reward function, which means that what we want to do is translated into a numerical reward. Now, we use sometimes the word autonomous, and we like to put it in quotes as well, between quotes. We are the engineers who develop those systems. But of course, in daily life, the word autonomous doesn't mean what engineers mean. Engineers have used this word by extension because the machine works on its own without human action. Once it's programmed, once it's developed, it is developed to work in a given domain, to achieve given tasks. And if it is able to adapt more or less to environment changes, we call it autonomous. But of course, it's not autonomous in the sense that humans are. It doesn't decide for its own goals and its own actions. It is based on the algorithm that we have built or the data that has been statistically processed. Now, regarding autonomy, there is a difference between autonomy and automation. And this difference is very difficult to grasp. And this is why it's easy to fall into the autonomy pit, if I may say so, in our language, because this is related to complexity. And complexity is not easy to measure, but we can have some measures of complexity. The more the task is complex, which means has different possible actions within it, or the domain is complex, which means there are many, many parameters that define this domain, we tend to say it's more autonomous. We leave the automated part, where usually, for example, you have an automated metro, the environment is very simple, it's not the station, and the task is very simple as well. So, and this is why engineers used to develop autonomous systems, and we use this word, hence autonomous cars, but they are not autonomous again. They are self-driving, or even self here is not appropriate. They have automated driving functions. And as you know, those cars, actually, we don't know how to make them in complex environments, such as cities. We know how to make them in more simple environments, such as highways. So you see, this complexity issue is really key to define this notion of autonomy. And what we tend to use is to simplify the environment, simplify the tasks, so that we can build a machine to do the task. Now, let me focus on machine learning, because this is a core technology that is used today. When you hear people speaking about artificial intelligence today, 99% of the cases, they mean machine learning. 20 years ago, 99 of the cases, they mean deductive reasoning or probabilistic reasoning. The change happened around 2012, because those technology, machine learning, and specifically deep learning, became more performant than symbolic or deductive or Bayesian mechanisms, because of the availability of data and because of the speed of computing. Mainly, these are the two main reasons, but there are other reasons as well. Of course, sharing data is important. So they are using neural nets. Neural nets are mathematical functions that can approximate almost any function, and optimization algorithm. And there are three main categories. Supervised learning, in which the answer is known, provided. So you have a kind of way to make your model, your computational model, your statistical model converge on the real answer, the exact answer. It will remain statistical. Unsupervised, the algorithm will have its own capacity to decompose the data set into different classes or categories. And for this, you have different criteria, such as, for example, resemblance, with what we call neighborhood in the data, and reinforcement learning, which again reinforces actions that are the most promising, which means that have the highest rewards. Now, so much for the definitions. Let's see the issue, because we are speaking about ethics. We are actually addressing what could go wrong in a way. And ethics is a deliberation. This is why it's complex and it's different. It's difficult for us to make decisions when you have ethical deliberation, because we need to identify values, human values that are impacted by the systems and or impacted by our behavior, and decide on the best course of action. And this is very difficult. But let's see the issues. One very known issue related to fairness, which is a complex concept, is data bias. Now, this is an example of supervised learning in which a machine learning process has learned to recognize scenes, people, etc., from images which are labeled. They are labeled by humans, of course. And on this image that you see some colors, and the colors are the superimposition of the neural nets, and the colors show the intensity of the synaptic weights, which means the more it is red, the more it is this part of the image which is contributing to the answer. And so you see on the left-hand side a scene where you see a woman and an office scene, and under the red part, it's a computer screen. And what the system recognizes here is a man sitting on a desk, at the desk, with a laptop computer. So obviously this is wrong. This caption comes from the set of images that have been learned, but why is it a man? Now the answer is that the system has looked mostly on the computer screen. This is the red part. So the system has statistically associated a computer screen with a man and not with a woman, because in the data set that was used to learn, maybe 90% of the, I don't know exactly the figure, but maybe in 90% of the images, it was a man. So this is what was predicted. It's a man. If you change the synaptic weights so that the system looks elsewhere at the person, then it will recognize a woman. So now this is the one main problem. It's because the data is biased because it doesn't represent the population that is impacted by the system. And also the system, and that's another problem, makes correlations with parts of the images that are not what you would think. As soon as a statistically computer screen comes with men, everything will be interpreted in this direction. So on the right side, you have a similar example with a tennisman. Now, that's one problem. Other problem is robustness. You see on the left-hand side, road signs. So when you want to build automated cars, you want them to stop at the stop sign. You want them to correctly read road signs. And of course, this has to be very robust. Otherwise, the car can have accidents. Now, in this example, some small changes have been made to the signs. You see the stop sign has some stickers on it, and this makes the learning system interpret this image as speed limit 45. We are speaking about North American road signs here. So stop sign becomes speed limit 45. It means small variations lead to big changes. And of course, again, there's a reason for that. It's not by chance. It's because some similarity between the stop sign with the stickers to speed limit 45 made the score higher for speed limit 45. But this is what the system has done. On the right-hand side, you have images of several kinds of objects, like a school bus or a scooter or a fire truck. And you have a number that says the confidence of the system in its result, in its prediction. So you see, for example, school bus has been correctly predicted with confidence 1. But to change you change the attitude, the pose of the object, and it becomes completely a different thing with very high confidence as well, like garbage truck or punching bag. A motor scooter become parachute, even with 1% higher certainty. So again, this means that what the system looks at, what the system interprets, is not what you would think as a human. It's some pixel alignments, some pixel correlations, etc. And there is some correlation with a parachute with this attitude of the scooter. No, maybe not. It's maybe the background, as we have learned in the previous example, that made this prediction. It's not because it saw a scooter. Maybe it saw some blue, or maybe it saw the sky and the green prairie. That was what influenced maybe the result. Now, if we go to maybe a more even a more critical application, which is medicine and medical imagery, in this paper, the authors have made some variations, very, very small variations in the images. And these small variations led to a misinterpretation, which means the system has interpreted as malformation some figures, some parts of the images, whereas the patient didn't have any of these. So small variations lead to big changes in the interpretation, and these are due to instabilities. Again, all this is grounded in the fact that it is statistical processing, a very advanced statistical processing, but statistical processing. We'll get back also to those limitations. Now, let me speak about some novel, not so novel for GANs, capacities for machine learning. So again, you see that the image is overlapping the text, and I will get back to that later, as I said in the first slide. GANs were invented in the 2015, 2017. This concept is interesting because if you put two neural nets in competition, one that would try to generate some data, for example, here an image from random noise, and the generation is guided by the fact that the fake image should look like a training set that has been given to it. So this neural net is going to learn to produce images that look like other real images. And there is another neural net that tries to identify the fake that has been built by the first net from the real, which is the training data set. And each of those two nets are going to work in competition, which means each one will try to produce the best results so that the other, the first one, so that the other doesn't recognize real from fake, and the other is learning to identify real from fake more and more. And when the system converges at a given point, it means that the fake image and the real images are almost indistinguishable, at least by the standards of the discriminator. And with this, we can create, and this is early work, so it's not perfect, but today it's almost perfect. We can transform an image which is capturing some reality into an image which is not capturing any reality. So, for example, zebra has been transformed into horses. It's not perfect, as you see. There are some parts of zebra on the horse, but it means that you can manufacture, you can make something which is not real. And of course, we are very much tending to believe what we see. A newer technology dating from 2017 is transformers. These are neural nets that have better capacities than recurrent neural nets. And the purpose here usually is to process sequential data structures, not images usually are not sequential, but a sequence of image is sequential. Language is sequential. Sentences are sequential sequences of words. And here, this process, this architecture enables to process the sequences while keeping track of other sequences which are far from the focus point. So you can correlate words, sentences with a more contextual part of a text. And you can compose also images, not necessarily locally, but also in remote parts of images. So this led to development of systems that are of a different nature than the ones that I have mentioned. And these systems are called large language model. So when you use natural language processing software today, including, for example, translation, you probably are going to use such a technology. So the principle is to use a large amount of data, like data on the internet, like Wikipedia, for example, or other databases, very large databases that have that embed a lot of knowledge, and then this learning process enables the system actually to be prepared to process additional data in a given domain, and therefore it will become able to interpret more data in more situations than it has been trained on initially. So you probably heard about systems such as GPT-3, Lambda, BERT, etc. All are, and Bloom. So we spoke about sovereignty. Bloom runs on the Jean Zay Computing Center, by the way. They have hundreds of billions of parameters. And Bloom is the only one actually that addresses many languages. It's not in English, 59 languages, including programming languages. So it can generate computer programs. So now these systems, again, can produce text which looks like human written text. From this, we move to something different. You know, we speak about AI as weak AI, which means focused on a specific domain. It doesn't do anything else from this domain. Now we have new systems, and DeepMind has announced Gato, which is a general purpose system. It's based on this technology, and it can be trained on very large sets of data, and then more specialized in many domains, the same system. So you have a general purpose system that is starting to appear. It can work on languages or on robotics control or on image interpretation, etc. Fine. So now that we have spoken about limitations and new capabilities, let's see what are the issues that we have to reflect upon when we speak about the ethical consequences of these technologies. First, let me speak about digital. So let me speak about digital technologies in general, the digital transformation that we are witnessing, and why do we need digital ethics? Now, first, we are using those systems not because we want to, or not only because we want to. Of course, some usefulness of those systems have dictated that we use them, but also they are imposed on us. Now, for example, I prepared my presentation using a software called Keynote that runs on Mac. And when I arrived here, I was told that I should provide a copy of my presentation to be put on this computer, which is a PC, doesn't know about Keynote. And therefore, I had to transform my Keynote presentation into PowerPoint. Now, of course, this doesn't go without mistakes because the transformation software isn't perfect. And you have seen two examples of these mistakes. The title page, Ersin, has disappeared. It was too high up. And the image 2 or 3 transparencies ago here was overlapping on the text. Now, of course, this I didn't want, but I had to abide because I have no choice. So much for human control and human oversight. The system has been imposed on me. I didn't have the choice. So when we will get back to when we go to human oversight and human agency, let's just keep this in mind for a very small thing that we admit, but which is actually we are facing every day. Now, the massive amount of data that is used, the massive use of automation, because this is what AI systems do. They automate a lot of tasks. Physical automation is robotics, and software automation is all the data processing. Transform our relation to work, of course, positively, but also negatively, because people would not do tasks that they were doing before. Now, I'm not speaking necessarily about jobs. I'm speaking about tasks. And often the answer is, well, those are repetitive tasks and they are tiring, even if it's about text reading, etc., and curation. So let's do them by machine. There is a major flaw in this reasoning. How do we learn? How do we learn? We learn by doing tasks which are not necessarily intelligent. We learn by reading texts, by correlating things, but intelligently correlating things, by making bridges between concepts, by just trying to go into some details of data that are given to us or that we use. And from this, we have some ideas and we gain some knowledge. A radiologist isn't going out of the medical school knowing to read images. He or she will be trained doing this by looking on hundreds of images, not thousands maybe, but this is what enable her or him to become more competent. If we give this task to the machine and we say, well, now we are going to focus only on the high-level part of the job, you will necessarily become incompetent. And of course, when you become incompetent, the competence will reside in the machine result. And we can always say human oversight. There will be no capacity, no knowledge with this human to actually exert this oversight. Other problems, human relationships. I see a lot of people every day sitting side by side, but looking on their phones. Limitations that I mentioned, decisions impacting humans. Very minor decision was this transformation of my slide, but there are more important ones. With systems such as those large language model, which can produce text as if it was written by humans, there become to be confusion between human capacities and machine capacities, and humans and machines. And of course, impact on the planet of those technologies because of computing time, because also of the physical resources to build the large data centers that we use, etc. Now, specifically about machine learning, there are additional issues that I try to show in my examples. And these examples are just address, for example, the fact that there is bias due to data, but actually the bias is also due to the design of the system. Because when you design a system, you put a given architecture, you put some semantics in the interpretation of data. This comes from us, from humans, from the designers, and this semantic is actually what makes the interpretation. I spoke about data bias, but also we must know that since these systems are in production and are more and more developed, there are almost no verification validation processes and qualification of results. This is a new way to build software systems. In the past, you had software systems, software engineering disciplines that were focused on verifying, validating the software, and not just validating that the program was correct, but also that the result was what we expect. And there were means to address, for example, dependability issue of those systems. This is very classical in computer engineering, but has been completely forgotten by the development of AI-based software, because now we have one pipeline, which is from data to prediction to result, and apply the result. It's not embedded in the system that actually includes safety processes, validation, etc. There are reasons for this, and most of the reasons are related to the speed of production and the speed for coming to market. I spoke already about the black box fact that it has a lot of parameters, and of course, something which is positive in theory, it's reuse of components of software systems that have been built by others, but you have no guarantee on their quality. Now, by design, the system will correlate things which shouldn't be correlated, and there is no causality to understand what has actually caused the result, but just the correlation, and no explainability. You don't have a system. Now, of course, this is a research domain, very active one, and there are very interesting results, but to date, we cannot say that we have a perfect solution for explicability. One example is what I've shown with the images on bias, with the red part, etc. This can explain to us why the system has arrived to a given conclusion, but we made the explanation actually, and it's just a representation, a visual representation. Also, computations are on the syntactic level. The system does not really understand any semantics about what it says. When it says, for example, a man sitting at a desk, it doesn't know what is a man, what is a desk, and what is a computer. It's just a label that has been put on the image by humans who understand what this means. So actually, the system is not unfair. It's just produced its results. It wasn't really the system who decided to discriminate women from men. It doesn't know what women are and what men are. It's just the result of its programming of its data. The fact that the system doesn't understand what it's doing is really key, because we tend to project on the system that it understands, and it doesn't, of course. I spoke already about cost. So the problem is that we need systems that reduce the risk and are trustworthy. This is necessary because you don't have any ethical rules in academic AI research, actually. There is one exception I'll mention at the end. The AI research, and this is a change of paradigm, very advanced AI research is happening in industry and not in academia necessarily. I'm not saying academia are bad, but they have less data, they have less access to computing. And you have no ethical oversight in general. Some industries are trying to put this in place, but that's not very frequent. And of course, you have applications in critical domains. I showed examples, and also applications in threatening human rights. For example, using AI systems in justice, using AI systems to decide for recruitment. Yeah, we discussed with one guy doing this just a few days ago with Catherine, and we're really shocked. So you need robustness, you need safety, but you need ethics, and ethics is related to governance. And you need, of course, transparency, explainability as ways to implement this. Now, it is always a human responsibility. It's not the machine. Some people tried or are still trying to say, well, it's the machine's fault. Let's give the responsibility to the machine, and of course, we will give we will identify some capital that will pay for the cost of the damage, and everyone is happy. No. So the IEEE Global Initiative on Ethics of Autonomous and Intelligent Systems was actually started in 2016 because of this, because we wanted to ensure that every stakeholder I'm reading involved in the design development of AI systems, and actually we say autonomous and intelligent systems, is educated, trained, and empowered to prioritize ethical considerations so that these technologies are advanced for the benefit of humanity. Now, the Global Partnership on AI, which is an international organizations of states, started in 2020, currently 25 member states, including most of Europe, United States, Canada, Mexico. I'm not going to mention them all. Japan, New Zealand, Singapore, is an organization that wants to actually develop AI systems and share this development. So the terms of reference say that it's meant to support and guide the responsible adoption of AI that is grounded in human rights, inclusion, diversity, innovation, economic growth. The innovation, economic growth is important to those states, and the OECD actually is hosting the secretariat of this organization, and social benefit while seeking to address the UN Sustainable Development Goals. So this means that the human responsibility is actually there. Now, to do this, to achieve this, people try to come up with some ethical principles, and they looked at biomedical ethics as a source of inspiration. As you know, biomedical ethics was actually become an issue after World War II. And four principles have been identified to guide biomedical ethics. And these principles are respect of autonomy, autonomy of the impacted persons, of course, and this comes from the autonomy of persons, right? The principle of non-maleficence, the principle of beneficence, and the principle of justice, which is related to fairness, but not only. So when we try to come up with principles in the domain of computer science and digital technologies and AI, we found out also that practically the four principles of biomedical ethics were often translated into a risk-benefit balance, which means that yes, there is this principle of autonomy, but autonomy means also ability to understand what is at stake. And most people, when it comes to medicine, don't understand what is at stake. The patient don't understand what, because they are not medical doctors. So their autonomy is limited. You can explain things, but of course the explanation given by the doctor is a transformation of the actual knowledge into very simple, understandable things. And justice is related to the fact that everyone should have access to medication, which is not the case necessarily, and the same quality of medication. So it's mostly the balance between non-maleficence and beneficence. Granted that in medicine, in biology, the system is the system or product or whatever is necessarily beneficial by design. It cannot not be beneficial, because this is why actually it has been put in place. So to achieve this trustworthiness thing, the European Commission has recruited 52 persons to constitute the high-level expert group on AI, and in 2018 and in 2019, and they proposed a framework for trustworthy AI. The idea of trust is central to this approach, that if you adopt a technology, you have to trust it. Now, what are the 4 principles of trustworthy AI inspired by the principles of biomedical ethics? Well, you find 3 of them coming from biomedical ethics: autonomy, preserve human agency and control, that I lose when I go from Keynote to PowerPoint. Principle of non-maleficence, do no harm or don't exacerbate harm. Principle of justice, equal fairness, fair just distribution of benefits and cost. Very, very similar things. But beneficence was an issue because actually a lot of those systems are not beneficent. They are not neither beneficent. They are just systems that are developed for such or such reason. For example, video games, who can say that they are beneficent or not, depending. So there is no obligation of beneficence. It's not like in biomedical ethics. But there is another principle that emerged, which is explicability. We want to understand what those systems are doing and why. And this transparency, which this interoperability, there are different aspects to this principle. Auditability is really key to master the ethical issues. Now, from this, the high-level expert group has come up with 7 key requirements for trustworthy AI. I'm not going to detail, but these requirements, inspired by the principles, make them a little bit more concrete. Start with human agency and oversight. It's not an order, by the way. Technical robustness and safety, privacy and data governance, transparency, diversity, non-discrimination, social and environmental well-being. This is where beneficial comes back a little bit, and accountability. Now, how to do this? There are technical aspects, because, for example, robustness can be addressed at least partially with technical approaches, and non-technical aspects, which are the context, the governance framework in which, and tools that can be used. So regulation, but also codes of conduct in industry or in academia. Standards are a tool to build more trustworthy AI. I will tell you why in a second. Education, etc. The whole framework. Now, standards, that's one of the results of the work within the IEEE. I call this techno-ethics standards. Usually you have technical standards to build systems that can actually achieve some interoperability, or that can achieve some specifications. Here you have P7000 model process for addressing ethical concerns during system design. It's a value-based design approach that has been described in a standardized manner. What the European Union has done is to take these recommendations and build a proposal for a regulation. This is the AI Act under construction. And the Commission has adopted a risk-based approach, which actually regulates more, asks more compliance, more certification for systems that are meant to be used in more risky situations. And when the risk is too high for European standards, for European values, for example, social scoring, they are unacceptable, forbidden. Otherwise, you need just to have to be in conformity with 3 slides, with some conformity assessments. Now, on the other side of the Atlantic, NIST, National Institute for Standards and Technology, is working on a similar thing, which is not a regulation. In the United States, it's not about regulations. It's actually a framework. It's called risk management framework, AI risk management framework, developed by NIST, and it's not mandatory. It's not compulsory. You can. It's meant to be actually adopted by organizations, industry, etc. But you don't have to. And they define trustworthy AI characteristics a little bit differently from the high-level expert group. And I've put here the correspondence. So you can see that, for example, we have valid, reliable, safe, secure, and resilient. This is number two. It's about technical robustness and safety. Number three, privacy enhanced. It's about data governance and fairness and privacy and data governance. Number five is about fairness in human in the edge layer. And number four, transparency, is explainable and interpretable. And there is something which is all over, accountable and transparent, which looks like the F 4 and 7. So two are, something is missing. Number one, human agency and oversight. It's not here, not explicitly at least. And another thing is missing, social and environmental well-being. Again, it doesn't mean it's completely overlooked, but it's not in the characteristic. So these are different approaches. Let me just conclude. No, before concluding, I had the slide saying that maybe in parallel to risk-based approaches, we should look at value-based design approaches, which are a different way. They don't avoid a risk reflection on risks and risk mitigation, but we start from values. We try to identify the values of the impacted stakeholders, people who are using the system or impacted by the systems. And the ethical deliberation is about the priorities among those values, because they might be in tension. And we have to build the system. If we have to build the system, it's not mandatory that we use, for example, AI, to address the objectives, by designing the technical specifications so that they comply with the ethical choices that we have made when we compared values and priorities. And this has to be evaluated. Now, my last slide, just some takeaways. So if there are some questions, I'm happy to take questions. But see this ethical assessment based on the compliance with the high-level extra rules 7 key requirements is a way to address those issues. And the good news, as you know, is that it is requested in EU projects. So we have some ethics when you build a European project and you submit it, you have some ethics assessment, which is based on the key requirements. And that's a good start for academic research, at least, but not only, because you have also industry, which is involved in these projects. Thank you very much.
Thank you very much, Raja. So we have time for a few questions. Yes, I will start with one short question, complex but short, about education. As you said, our autonomy is at challenge to understand what happens. Okay, so in the context that you show us, what is the place of education? How can we communicate about education?
Yes, that's an important and it's not a simple question, but education is really key to build this human agency, and it's related to understanding what we are talking about. So what is AI and how it works? What are the positive sides? What are the limitations? How we can address it? How we can cope with it? This education, in my opinion, has to be provided in schools. I mean, probably high schools, maybe what in France you call college, which is intermediate levels. In my opinion, not in primary school, because first we have to build the reasoning mechanisms and not to start to think like an algorithm. I know that there are a lot of colleagues in computer science that want computer science to be taught early in the school curricula. I think if we start to think like an algorithm, that would be a dangerous path to in our capacity of really reflecting and reasoning. So starting with schools, and also, of course, general public. I mean, conferences, books, whatever, to the general public, and of course, educating those who are developing those systems, which means in university. So it's all over the our actually development process, mental development process, that we have to do this, and this is starting to happen.
Thank you. Eugenio Oliveira. I'm from an AI lab at University of Porto. Thank you, Raja, for your very nice and wise intervention, talk. And of course, I fully agree with most of your messages. And I don't feel that's a problem that the AI researchers follows the regulation and the ethic guidelines. I think that the real problem is that after deployment of those systems, of course, you still need more robustness, more transparency, more explainability. No doubt about that. But after deployment, you can feed all these good systems with many kinds of data sets, which could be corrupt, as you said before also. And so I believe that data curation and data integrity is a real crucial problem. I can tell you a story. 3 or 4 years ago in California, in a forum like that, someone in the audience just put me the question, please, I'm not really very much interested in AI. I'm interested in counter AI. I don't know if you know what is counter AI. Meaning that, okay, you just have to tell me what can I do, or what shall I do with my data in order to get my intended result, outcome. So that's how military and other agencies look to AI, some of them at least. Just how to manipulate data in order to find out the intended result. Do you have any idea about that? Of course, remember about these laws standing for lethal autonomous weapon systems. Thank you.
So I don't know if I'm answering your question, but I think in terms, for example, of military applications, the military are not unethical. They do war, but they are not unethical by definition. There are most, I would say, in military leadership and agencies, etc., want to abide with the Geneva Conventions, with the necessity, with the principles of the humanitarian law. Now, I'm not saying it's easy, but I don't think they want just to go to war like that. So when they come to use AI systems, also for their own benefit, they don't want the target to be missed. They want the right target to be actually designated. And it becomes their responsibility. Again, I'm not speaking for war here. I'm saying there is war. It's not, the question is not, is there war or not? But these people are doing war. So when they want to achieve their purposes, they want the system to be reliable. So it's not contrary to what we speak about when we say trustworthy systems, explainability, etc., etc. They want the system to be reliable. So they are not trying to modify in a way the data or to manipulate it so that they arrive to some purpose which is not the correct purpose, that or just purpose. That's my personal opinion, but it doesn't mean that there are not also possibilities for manipulating data. But I agree with you that it's a big issue, not only for military applications. The quality of data it's a big issue, which is very difficult to address. And because we don't have, in general, methodology to prove the quality of data. It depends on the domain. It depends on a lot of criteria.
Okay, there is some, okay. Be careful not to touch it, I'm sorry. Yes, Andy.
Yeah, thank you. Andy Rauber from TU Wien and SBA Research. Thank you very much for your talk, and I agree with basically all the points that you've listed in terms of what AI is lacking, what we need to do research on. But just for the sake of making a counter argument, might it be that we are more critical with AI than we are with human beings taking decisions? Or phrasing it differently, how good would results have to be for them to be good enough? Because we know that optical illusions exist for humans as well, and they're fascinating. Bias exists with humans as well. Intransparent decision-making processes are all about us. So how good would our AI research have to be in order to be acceptable in terms of ethical standards, competing with unethical human behaviors?
Thank you. A very important question, actually. Well, yes, we must be much more we must ask much more from AI systems, not just AI system, any technology. We know that humans are imperfect. We know that they have flaws. We know that sometimes they are mean. We know all this, but they are humans, and they make decisions, and they are responsible for their decisions. This is why we have laws and we have jails, which means people are doing things which are bad. And we have a social organization, and we have ethical principles to live the good life. So a technology, a system, is outside of this realm. So we shouldn't compare it. We shouldn't say, I'm asking more from this system than I would ask from a human being. And I'm applying things to anything, not just to AI, actually. Okay. Because we get back to the beneficial aspect. We build this technology to achieve a certain goal. We want this goal to be achieved correctly, not approximately. I want to go into a plane to have a flight and arrive at destination. I don't want to hear that I have only 90% chances to arrive at destinations. Now I have a chance to crash. It's 10 to minus 8. I accept this risk. So if I don't take a plane, it would be for another reason. But so yes, we need to ensure the quality insurance. We ensure the quality of the service that the system provide much more than if it were just one single human. And also, this is why we have human organizations. The plane is not safe just because of the pilot. Actually, as you know, the pilot doesn't fly the plane most of the time. It's an automated system, automated pilot. So, but there is an organization, there is regulation, there is certification, etc., development processes that makes me believe this 10 minus 8. And if I don't trust the technology, basically. So trustworthiness is also something that is usually between humans. I trust humans, I don't trust things. But I trust the process that produces this thing. And therefore, when we say we want more from from AI than what we want from human, no. We actually want the correct human governance in place to trust the technology.
Thank you, Raja. So thank you again. I think we need now to make a break. Yes, Anaël? Yeah, okay. I think it's important to have also outside people to be involved. So you have to tell us maybe all the questions, and then Raja, you
yes, I will
answer everything.
from a representative of business, we receive the unconfirmed information that currently there exist 200 reference frameworks of ethical compliance. How can we reduce, and are institutions for different branches needed?
So I think there are not 200 ethical compliance. There are 200 declarations or documents, etc., about what is ethics, AI ethics, etc. That's right, and they are not different. So much different. They converge to very similar actually requirements. So I would say that I presented two frameworks, one which is developed in Europe, one which is developed in the United States. There are, of course, other frameworks. I didn't speak what's happening in China, for example. But these frameworks converge, which means we have actually a smaller number of requirements, less than 10 actually. So it's easier maybe, but when you look to those frameworks, it's easier to find the proper assessment, possible assessment tool. And by the way, I didn't mention, but in the European high-level expert group, we have developed a software system which is online, which is called the AI Trustworthy AI Assessment List, ALTAI, LTAI. If you look for it, so you don't go to the Altai Mountains, but find your way with AI. And you have a software tool that can help you assess if your software system, without disclosing anything about it, is in accordance with the high-level expert group 70 requirements. I believe NIST is going to develop something similar. You have also a large database with the OECD, very large. It's being curated in a way so here you find a lot indeed of tools and frameworks, but this is certainly going to focus. So I would say there are not so many when you look to the how they converge to similar requirements.